5 years ago, in the Alberta oil sands, 1,600 birds died after landing in a tailings pond and getting covered in mine waste. Now, this tragedy motivated the Alberta government to step up their regulations on land reclamation. This means that oil sands companies had to speed up the rate at which they converted their mine land back to a natural state. Now, this is no easy task because we're dealing with mining on a scale that we have never seen before. Just to give you some context, the surface mineable area is 6 times the size of New York City. And when they're done with this mining, it has to be turned back into a forest or a wetland. So one of our current reclamation strategies is using something called composite tailings. They take their waste material, they mix it with sand and gypsum, which is a sulfur mineral. And it gives you this yogurty, quicksand-like material. In order to build on it, you need to put sand on top. So you can see from my schematic, I've got tailings on the bottom, sand on top, and on the very top, they've built this beautiful wetland. Now, this wetland is the first of its kind to ever be built in the oil sands, which makes this study the first to ever look at sulfur in a deposit like this. Now, why do we care about sulfur? Well, hydrogen sulfide gas is a potential waste product that could develop in a deposit like this. And hydrogen sulfide gas is corrosive, explosive, and toxic. So oil sand companies really want to minimize the generation of hydrogen sulfide gas so that they can avoid risk. Now, one thing we do know that generates hydrogen sulfide gas is bacteria, and we have bacteria throughout this entire deposit. And we're essentially feeding these bacteria with the sulfate from our waste and the carbon from our wetland, so we have the potential recipe for very high hydrogen sulfide gas generation. So the objective of my study was to see, first, do we have hydrogen sulfide throughout this entire deposit? And second, do we have it at levels that we should worry about? Now, to answer the first question, yes, I did find hydrogen sulfide gas throughout this entire deposit, but at the surface of the wetland, these levels were so low that from a management perspective, it's a good thing. We don't have to worry about it. But if you look a little bit deeper, we actually find that our highest levels of sulfide are in the sand layer, not in the mine waste like you might expect. This tells us that something's moving around. And the levels of sulfide that I found sandwiched between this wetland and the waste are actually 15 times the safe human health limit for exposure. Not to mention that down the line, if this sulfide was ever to come out in the atmosphere long term, we have a risk for explosion on our hands. So, the importance of my research tells you that oil sands companies have to consider sulfur chemistry when they're designing these reclamation wetland deposits. Because if they're not thinking of potential cycling between sulfur and bacteria, then they're not going to have deposits that are safe and sustainable in the long term. Thanks.